Okay, good evening, everyone. Welcome to the 24th Rachel Carson Forum. It's a pleasure to see all of you in the room. I look around the room and I see alumni, I see faculty, I see guests, I see potential new students, I see our current student body, and I'm very pleased to welcome to you here to see all of you in the room. My name is Martha Henderson. I'm the director of the graduate program on the environment, which awards the Master of Environmental Studies degree. The student body that we have are slowly working away towards earning that degree, and we're very proud of them as they have progressed through the program. The first years have been very active, but the second years are getting ready to turn in their thesis, finish and turn those theses into their advisors, and we'll be celebrating their graduation in a couple months. So thank you so much for coming this evening. I want to especially thank the students that have put this program on, the MESA, Master Environmental Studies Student Association, particularly Kelly, Bethany, and Lauren. I think it's really wonderful, and I wish us to give them a hand right there, your warm thanks. We'll say that they are representative of our current student body. Our current student body, both in the first and second year class, which is almost 100 students, is close to 70% women. And this has just been one of the most wonderful parts for me being the director over the last 5 years, is to see the growth in the number of women coming into the program, graduating and moving on into very important positions in solving the environmental issues that we have before us today. I'm happy to see men in the room as well. I'm happy to see that there's a woman on the podium tonight. But it's been great, and I think it's really important that we remember how important women have been in defining the environment and helping us understand the problems, some of the causes, and the solutions for our environmental issues that we face in North America and the rest of the world. Most important, this is the Rachel Carson Forum. Rachel Carson, I'm sure most of you know, was a very important woman leader in the environmental movement in the United States. She wrote a very important book called Silent Spring, and I suspect that most of you have read it. We do require our incoming students to read this book. The book came out in the 60s and was the first time that the whole universe really began to understand the impacts of chemicals, pesticides, particularly DDT, and the impacts that had on the environment. Through her book, through leadership, including some of the older faculty on this campus, DDT was banned for use in the United States. And that was a very important step in leadership in trying to protect and begin the environmental awareness. And it was very important in starting and beginning these kinds of graduate programs where we look at environmental issues as a set of relationships between the social and natural sciences. Silent Spring is a very important book. She had other books. The now just recently died author Peter Mathiasen stated that her books that included books about the seashore and other parts of the natural history of our continent were some of the most beautifully written environmental and nature writing texts that we have. And I think it's very important to remember Rachel Carson as someone, as an early woman leader in the environmental movement, was somewhat relegated to being a field person, to being the editor in the back room, and not really allowed to take a very active leadership voice in the environmental movement and environmental causes. It's only after her death that we really have come to appreciate the power of her words, both in writing and her presentations in public, and particularly in front of Congress. I think in my own work in environmental issues and trying to understand the environment, as a geographer, I've been interested in looking at the impact of wildland fire on our environment and the causes of that. And for me, as a social scientist, I have come to read and to study that wild and fire issues from a perspective of culture and of politics and of gender relations. And there is some evidence to say that some of the very strong fires that we have now in the West and in Mediterranean regions and in Australia have to do with the way we have aggressively transformed landscapes, aggressively tried to control those particular land areas, and how lands have been burned by certain groups of people to acquire power and economic advantage. That those wild, intense fires are out of control. And I'd like us to remember that for just a little bit, to think that perhaps there are other ways of coming to define the environment. That from a different perspective, perhaps more the perspective that Rachel Carson and other women can lead us to, that we might remember that the best fires are those that are slow, burning embers moving slowly across the landscape to help integrate various species, to create flexible ecosystems and ones in which humans, as well as the rest of the natural world, can survive. So I think that there's a lot of hope as we see classes of 70% women, women moving into jobs and leadership roles around in the environment. I encourage all of you to keep that flame going, to remember that we all have an important role in transforming the natural world in one which we work with and live within, not conquer and not control. So with that, I'm very happy to introduce the facilitator for this evening. He wears many different hats, but I would like to most remember him at this moment as an alum of this program and as someone who created a very powerful organization that keeps that flame going, Climate Solutions. But today he's here to be the facilitator of this evening's event. So welcome, Reese Roth, and we'll turn it over to you now.
Really appreciate that, Martha, and congratulations to the women leaders of Mesa for pulling together this great event. It's very exciting to be here. This panel is definitely a distinguished panel. I'm very excited about it. We have an absolute world-class scientist, Richard Feely, participating, and two practitioners of responding to climate change who are in the trenches every day doing work in real communities, our community, to try to work through all the issues involved in responding to this climate crisis that we have. So it's going to be fascinating to hear from these folks. I think one of the signature hallmarks of an evergreen education, of the evergreen way, is the interdisciplinary approach, interdisciplinary studies. And I think there's no issue that is perhaps more interdisciplinary than climate change. When I did my master's thesis back in, this was like 1989. This is before, I didn't get the memo that said choose a well-bounded, smart, kind of finite thesis topic. I did the theory and evidence of the greenhouse effect, this broad literature survey of the science of climate change at that time. I remember just being absolutely astounded and excited by this, what I saw as a scientific renaissance that was happening as the scientists tried to get their arms around and build models, mathematical models by which they could sort of test what will happen in the future as we ramp up the greenhouse gas content in the atmosphere. And it started with the atmospheric physicists and the chemists sort of putting that together, and then, boy, we really got to bring in the hydrologists, and then we really got to bring in the ice people, like I think it's called the cryosphere. I don't know, what are ice people called? Are they cryologists or cryers? I don't know. The marine biologists had to be brought in. The forestry people had to be brought in. All these scientists suddenly were thrust into collaborating and integrating their work to build more and more sophisticated models that better and better reflected the incredibly nuanced, complex and fully integrated and interdisciplinary world of the Earth ecosystem. So it's been an amazing process, and it felt like that was just the beginning of it, and it was sort of unfolding before our eyes at that point, and it's evolved since then. Let me just say a word about the Center for Sustainable Infrastructure, which I'm very happy to say that I am now an employee of the Evergreen State College. After Climate Solutions, I decided to launch a new career adventure. And the Center for Sustainable Infrastructure is really, I think the vision motivating it is for Washington and Oregon to become national leaders in sustainable infrastructure innovation, to shift how we invest in our transportation systems, our energy systems, our water-based systems, and our waste management systems. We're going to have to spend billions upon billions upon billions of dollars just to keep on these kind of systems, just to keep society functioning in the decades ahead. And if we do it in the way that we've done it in the past 30 years and just sort of replicate what we already have, we're not going to be responding to climate change. We're not going to get where we need to go. We need to transform how we make those investments, and the center, I think, will play a key role in helping to galvanize the innovators and thought leaders in the region around a shared vision and action strategy, and help to cultivate a new generation of infrastructure professionals that can be change agents and can help facilitate sustainable new ways of going about investing in these really, really critical systems. Without further ado about what I'm doing, I want to introduce our first speaker, Dr. Richard Feely. As it says in your program, he is the senior scientist and project leader at the PMEL Carbon Group, which is a NOAA scientific group. And he was honored with the prestigious Heinz Environmental Award in 2010. What the program doesn't say is he's also a Nobel Peace Prize winner with the Intergovernmental Panel on Climate Change. And I think there were about 2,000 scientists who were part of that group, but he is actually an absolute pioneer in the arena of ocean acidification. He told me that he was doing papers on ocean acidification as early as 1982, which is really remarkable. It didn't get on my radar really until like maybe 2006. And it was a case where it finally got traction when you started to work with the biologists and bring home the biological consequences of ocean acidification. He was also, and so he is the lead author of the ocean acidification chapter of the IPCC's Working Group 1 report. This is a world-class, preeminent scientist that we're privileged to have here tonight. He was also a member of Governor Gregoire's Blue Ribbon Commission on Ocean Acidification, and he was asked to represent the science at the media event that the governor held to release the findings of the Blue Ribbon Commission. So we're very, very fortunate to have Dr. Richard Feely here tonight. Please welcome him.
Gonna work?
There it is. There it is.
All right. Wanted to start out this presentation. Does everybody know what this is? It's a marine pteropod. There are 32 species of pteropods in the world oceans, and my postdoc who works with me is the world specialist on pteropods, Dr. Nina Benarczyk. Would you stand up, please? That was her movie. We brought her over from Europe to study marine pteropods and ocean acidification here off our coast, and her paper is coming out next week. So we're very proud to be able to show some of her very exciting research results. So what I'm going to talk about today is how serious ocean acidification is And I would love to have you ask questions afterwards, and we can have a dialogue about this. So I'm going to give you just an example of what the problem is, why it is, how serious it is, and what it means for the future. So we'll talk about ocean acidification as a process. We'll talk about why our coast along the Washington, Oregon coast is so vulnerable. And we'll talk about present and future impacts. As you all know, the burning of fossil fuels, coal, oil, and natural gas releases CO2 in the atmosphere, which increases the levels of CO2. Mankind has released about 2 trillion tons of carbon dioxide since the beginning of the industrial period. And about 30% of that carbon dioxide has already ended up in the oceans. It does so by exchanges across the air-sea interface and then penetrates downward into the water column, on average about 1,000 meters down into the water column. And so we're changing the chemistry of the oceans by this continual release of fossil fuel CO2 into the atmosphere. Now CO2 is unique because it reacts with water and forms carbonic acid. Everybody knows what carbonic acid is because when you have a bottle of soda water, that's carbonic acid. And about 28% of the CO2 has been taken up by the ocean. But over the course of history, about 95% of the CO2 we release in the atmosphere will end up in the oceans. And as we do so, we're going to decrease the pH. Now, through the IPCC process, we have been able to quantitatively understand those changes that are taking place. Most of it occurs because of burning of fossil fuels, coal, oil, and natural gas. Also, the destruction of our forests and the burning of those forests also release CO2 in the atmosphere. And right now, we're releasing almost 10 petagrams, 10 billion tons of carbon in the atmosphere every year. And about 45% of that remains in the atmosphere. They increase the CO2 levels in the atmosphere and cause global warming. About 27% gets retaken up into new forests, new forest land, and another 27% gets taken up into the oceans. We can study this process, and my colleagues from the Earth Systems Laboratory in Boulder have taken samples throughout the world. There are 67 stations throughout the world. They collect samples every week, and they bring them back to the laboratory. And this is my favorite slide of the CO2 record right here. I want to show that to you. So this is the South Pole, and this is the North Pole, and we're going to run just a 15-year record of the CO2. This is the average around the world of the CO2. And what I want you to notice is this is the breathing of the planet. With the uptake of carbon dioxide in the summertime into plants, and the release in the wintertime due to respiration. Most of the CO2 is emitted in the northern hemisphere, so we see most of that activity in the northern hemisphere. But everybody can see the baseline of CO2 increasing in the atmosphere every single year. It now increases at the rate of about 2 parts per million per year. And mankind is increasing the rate of release of CO2 in the atmosphere. It's on average now, we're increasing at about 2% per year. So we're not slowing it down, we're actually increasing that rate. And we can track that, and we track that very well with these beautiful records that our sister laboratory maintains. This was started by Dr. Charles Keeling from Scripps Institution of Oceanography and maintained by his laboratory until recently it was transferred over to the NOAA lab. And just as a snippet of Dr. Keeling's data set from Mauna Loa, you can see starting here just over a very short time period from 1989 to the present. And here's the corresponding CO2 record at Ocean Station Aloha right here. And you can see that the ocean CO2 is increasing at exactly the same rate as the atmosphere. It's taking up that CO2 in the ocean, and so that increase in ocean CO2 comes from the atmosphere. And here's the decrease in pH at those same stations taken from measurements, and we can see from measurements alone that we're acidifying the ocean. We acidify the ocean at about 0.02 pH units per decade. Now, as I said, the chemistry is very simple. CO2 reacts with water, form carbonic acid. That carbonic acid immediately dissociates to form a hydrogen ion. It's that hydrogen ion that gives us the acidity of the oceans. Now that hydrogen ion will then react with a carbonate ion. And this is particularly important because that carbonate ion is then consumed. So we're decreasing the carbonate ion as well. 99.99% of those hydrogen ions react with a carbonate ion. What's left over is what decreases the pH of seawater. This is the buffer reaction of seawater. And what we know from over time is that the pH of of the ocean, on average in pre-industrial, was 8.2. It's now 8.1. Mankind has changed the pH by 0.1 pH units, which is an increase of the hydrogen ion concentration on average in surface waters of about 30%. And that carbonate ion decrease, we measure that, and that's decreased 16%. Now the carbonate ion is particularly important because those species that form a calcium carbonate shell or skeleton uses that carbonate ion. So if we decrease that carbonate, it's harder for them to form their shell or skeleton. By the end of the century, with the business as usual scenario, we will see that the pH will decrease another 0.3 or 0.4 pH units, which is an increase in the acidity of the oceans of about 100 to 150%. So there's our future, and we're actually going faster than what those projections say. And that carbonate ion concentration, as you can see, will decrease by as much as 50%. We're on track for that right now. So what we know for certain from the IPCC process is that approximately 28% of the CO2 that's released in the atmosphere from fossil fuel burning has been taken up by the oceans. And that's increased the acidity of the oceans by 30%. And the ocean acidity is going to increase by 100 to 150% by the end of the century if we continue along that pathway. And the current rate of acidification is 10 times faster than we've seen over most of the geological past. So mankind is changing things faster than we've ever seen before. And here's an example of that. This was the pre-industrial rate of change. Here's where we were in the last century. This is the direction we're headed. This means the animals that live in the ocean have to adapt to these changes more rapidly than they did during their entire evolution. Now, a very important component of this, as I said earlier, is if you're going to make a shell or skeleton, you have to take a calcium atom and combine it with that carbonate to form calcium carbonate. All animals that form shells and skeletons produce this calcium carbonate. And we have a geochemical indicator of whether it's favorable to do that. We call that the saturation state. And if the saturation state is greater than 1, then they can produce your shell or skeleton. If it's less than 1, then the shells begin to dissolve. And we can study this in the ocean. That's actually what my job is, to figure out where that occurs. And I do that on a daily basis. And the common calcium carbonate minerals are aragonite, such things as corals and the pteropods, or calcite, which are things like coccolith and forams, things you study in the laboratory on a daily basis. And what we can do with these IPCC projections is to say what the ocean chemistry will look like in the future scenarios. So on the top panels, if we stop CO2 emissions right now, this would be the impact in the tropical ocean, the southern ocean, and the Arctic Ocean for saturation state and for pH changes. And what we can see is in a business as usual scenario, we would go from 8.2 pH all the way down to about 7.75, out to 2100. And it would stay that way for at least maybe 400 or 500 years until we slowly get back to the pre-industrial levels. And it takes maybe 10 to 30,000 years to get back to those pre-industrial levels. But if we reduce emissions right now, we can see we can have a very different pathway in which we can get back to pre-industrial levels within a few hundred years. This is the choice we have as mankind on how much we're going to affect the chemistry of the oceans in our future. Now, we studied this process by doing large-scale surveys of the global ocean from Antarctica to Alaska, from Japan to Mexico. We do all these cruises, 15 different laboratories from 11 different countries working together to gather these data. We take sample bottles from the surface to the bottom. We collect samples on moorings, we bring them back, and we can determine how much man-made CO2 is in the oceans. And we've done that, and we can see most of the anthropogenic CO2 is still in the upper part of the oceans, in the upper 1,000 meters or so. That's because of the slow circulation. Circulation of the ocean is very slow. It takes about 1,500 years to go one circuit from the North Atlantic to the Indian Ocean, to the bottom of the Pacific, and back up in the North Pacific. And so for that reason, most of that anthropogenic CO2 is in the upper part of the water column, where all the animals live. So what I do, my job is to determine where that undersaturation will take place, when will the animals shells begin to dissolve. Turns out in the Pacific, it's very shallow. It's about 200 meters along our coast, but can get onto our coastline. And when it does, it has an impact on our marine organisms. In the Atlantic, it's much deeper because of the general circulation. So with my colleagues from Woods Hole, we developed a model of what this would look like. So this is the saturation state of the oceans. Blue is good, red is bad. There's no political significance to this, just the way we did it. And you can see that in the warm tropical waters, the saturation state is high. They can produce their shells or skeletons just fine. In the Arctic region and Antarctic region, they're already struggling. This is the pre-industrial. And the reason for that is that more CO2 goes into colder water than open ocean water. This is the 1880 picture. I'm going to show you the changes that would take place out to 2100 with our models. And you can see by the 1930s and 40s, we're already changing the chemistry of the oceans. And by 2000, we've dramatically changed the chemistry of the ocean, but nowhere near as much as what we'll do over the next century. And by the end of the century, the entire Arctic Ocean, the North Pacific and North Atlantic will become corrosive top to bottom. The Antarctic Ocean will become corrosive top to bottom. And even the tropical oceans will be so much lower in saturation state, the coral reefs will decrease their rate of calcification anywhere from 30 to 60%. These are major, major changes in the chemistry of the ocean in our future. And this is what the pH of the oceans will look like. Right down here is the pH of the ocean in the pre-industrial. This is our future pH at 2100. Very, very dramatic changes. This is what the organisms have to be able to combat and evolve or adapt to. Now, along our coast, we have another problem. We have a natural process called upwelling. This occurs from April to November, and when the winds shift to coming out of the northwest, the waters come in from the deep ocean along the bottom, all the way to the surface, and then they go outward from the surface. That brings these very CO2-rich waters along the bottom, adding to the anthropogenic component from the surface. And so our waters along the bottom are much lower in pH already with that anthropogenic contribution. So along our coast, we see the same kind of pHs that we'll see throughout the surface ocean in the next century. So this is the reason why our region is most vulnerable to acidification. And it goes along the bottom all the way to the beach and then projects out from the beach. This is a model projection of what down upwelling will take place during the summer. This starts out on January 3rd. Notice the blue colors, that's the corrosive pH waters. Watch what happens during the course of the summer. So you start out, no upwelling taking place until you get to March or April. Then the upwelling occurs along the entire coastline, goes right to the beach and outward from the beach. It's upwelling at the time when most of the spawning take place. So this is the waters they're getting in the near bottom waters. Now I'm going to shift gears and talk about the work that Nina and our colleagues have done on marine organisms and how the effects take place. We have a lot of different tools to study this. We can study it in the laboratory. Many of our laboratories here and elsewhere study this by controlling the CO2 levels and looking at different organisms. We can do it in a mesocosm experiment, or we can do it out in the sea. Put a cap over there, add the CO2, and see what happens. We do all that. Here's a mesocosm experiment in the Arctic. We actually control the level of CO2. These are great big tubes that go to about 10 meters. And we studied the changes that take place at the very base of the food chain. And what we found is that the cyanobacteria are the ones that are most strongly stimulated by high CO2. Cyanobacteria have a lot of toxic poisons associated with them. Not necessarily a good thing. And the nanophytoplankton are moderately impacted, and it turns out some species, like diatoms, generally have very little impacts. You can see there will be a species shifts from one type of phytoplankton to another. It has enormous impacts on how the food chain will respond. So at the very basic level of the food chain, we see changes. So, just to summarize, when you have higher CO2, the CO2 concentration goes up, the bicarbonate goes up, the carbonate goes down, pH goes down. You have increase in photosynthesis because they're enrichment. You have decreasing calcification and large changes in physiology of organisms. In addition to that, we have increasing temperature, decreasing oxygen. So we have to think of the multiple stressors and the challenges of multiple stressors that climate change brings in. Higher temperatures, lower oxygen, and acidification. As scientists, we have to understand all three of these things occurring. Now it turns out calcification is a big deal for corals, coral reefs, and coral reef organisms provide a rookery for about 25% of all the sea life, the fish life on our planet. So it's really kind of important. And they're very susceptible to ocean acidification. They're one of the most sensitive species. And here's a very interesting experiment that took place where they went out to a coral reef system where there was naturally CO2 percolating from a volcano underneath the coral reef. This is in New Guinea. And they studied the CO2 bubbles coming out from the bottom. And you could see that 43 of 45 species of corals went away. They couldn't exist in this environment. So this represents the kind of pH changes in the future that we can study right now and study those impacts. Remember that calcifying organisms are also people food, and so we care about them, clams and oysters and lobsters, we care about that, but so do fish. Fish eat the shellfish as well for food. So it means it's an ecosystem change as well. And so we have to think of it not only from the point of view of the humans, but also the ecosystem. And what we found along our coast was that the oyster industry, the hatcheries along our coast, were finding that the water that was coming in was so acidified by this upwelling process that it was killing off the oyster larvae. Now I'm going to show you a little 2-minute movie of what their response was to this impact. We can get it to go. Oops. They tell this story beautifully.
From ABC News, this is Good Morning America, live from Times Square.
Welcome back, America, to our 40th annual Earth Day celebration. Oh, by the way, we wanted to talk a little bit about the health of the ocean here. Did you know that the 70% of the Earth's surface is covered by the oceans? And those oceans absorb about 20 million metric tons of greenhouse gases that we put into the air just about every day. Now, we never really thought there was a problem before, but now we're beginning to think it might be.
Mark Waggart and Sue Cudd have each dedicated 30 years of their lives to bringing oysters to our tables. Now the couple's found themselves thrust into the forefront of one of the newest, most pressing environmental issues of our time. And it all began with these tiny, delicate oyster larvae.
In 2007, all of a sudden our larvae started dying.
The husband and wife team run the Whiskey Creek Oyster Hatchery in Oregon, the largest independent producer of commercial oyster larvae in the country. They produce 10 billion a year for shellfish farmers around the world to grow into the oysters that we recognize. That is until their production plummeted to zero without any warning.
At first we thought, what are we doing wrong? After 30 years of being able to produce larvae, all of a sudden we can't.
Desperately, they turned to expert oceanographers. They discovered the Pacific water piped into the hatchery from Netarts Bay outside the door was to blame. And it wasn't just them.
This is where the Pacific Ocean meets Netarts Bay. Every day, those waves refresh this bay. That water is roughly filtered, heated a little bit, and pumped directly into these 8,000-gallon tanks. Inside the tank are roughly 40 million swimming oyster larvae. If they're not swimming, that's a problem.
Scientists discovered something was making the water too acidic, preventing oyster larvae from growing shells, and without the shells, it's certain death.
So that's their story. That oyster industry is about a $250 million industry along our coast. So you can see this has now become an economic importance. About 3,200 jobs are supported by these hatcheries. Another example of the same thing is the pteropods. Nina Benarthic has shown us that on our west coast, the acidification that is occurring right now is causing the pteropods the shells to begin to dissolve and have a significant impact along our coast from Washington, Oregon, and California. This is the first time that we've seen an animal in the wild being affected by the acidification right now, so it's a very important discovery. And here's an example of her experiments that she did last summer, showing what the dissolution had for CO2 experiments with pteropods. The shell is completely dissolved in 8 days. So they're very, very sensitive indicator species of ocean acidification. The food web is very important to us. The pteropods are eaten by salmon, and the first year pink salmon, they depend on pteropods for their livelihood. So you can see how this would work through the food chain, from the phytoplankton to the zooplankton, to the fish, to humans, to whales, to birds. So just like Rachel Carson learned that chemicals from mankind can affect the ecosystem way back 30, 40 years ago, we are now seeing that CO2, another man-made chemical, can have a major impact on our ecosystems. I think I'll stop there and we can take any questions.
And I'm sure you've got lots of questions in your mind. In your program, there's a little piece of paper titled "One Question Per Sheet." So, what if you have more than one question? You're only allowed one question.
There's extra paper at the table.
Okay, so hold your question, write it on here. We'll collect those up. We'll have a little intermission after the speakers speak, and then we'll come back and then get to your questions. We'll dive into those. So I want to introduce our next speaker, Andy Haub. He is the planning and engineering manager with the City of Olympia's Public Works Department. He's been with the Water Resources Program in our city since around 1990. And it wasn't long after that that he started to tackle the question of how sea level rise from changing climate and the warming of the planet could affect our community. And he's been at the forefront of that investigation and planning process in our community ever since. And I think it's safe to say that our community, because of Andy's leadership, is at the cutting edge nationally and has been for 2 decades now in really trying to understand what this could mean for us, and to respond and sort of build that into our the ongoing development of our community. So we're very fortunate to have his leadership in our community, and it's an extraordinary process that he's guided the community through, and we're lucky to have him here tonight to speak about it. So, Andy.
Thank you. We got oh yeah, you told me that before. Do I press forward? Yeah, okay. Well, good evening, and thank you. Thank you for including the City of Olympia in your environmental programming this week. We appreciate it. As environmental managers for the city, as water managers for the city, this is an important issue to us. It has been for some time. And we welcome the opportunity to be with our community discussing this. It's really key to our program is to lead these dialogues, help facilitate these dialogues within Olympia. So once again, thank you for inviting us. Since about 2007, maybe 2008, when Al Gore reminded us that we really had forgotten about climate change and we needed to start paying attention. City staff have really responded with a heightened sense of urgency, maybe a heightened sense of responsibility to this issue. And we've very deliberately put in place a program that we hope will institutionalize or maybe create the organizational capacity within the city government to sustain work on climate change and sea level rise indefinitely. That's our goal. We're not climate change or sea level rise scientists per se. We're not experts on that issue. We're municipal managers, and our intent is to respond to this challenge through our city government. Downtown is vulnerable to sea level rise. Downtown has always been vulnerable to sea level rise. It stems from its history. Most of downtown is built on fill material. It was dredged from Bud Inlet and placed over the water, and unfortunately at the time, maybe they didn't place enough. The tides come very close to our shoreline, and we have a long history of flooding, prolific flooding in the 40s and 50s and 60s, even into the 70s. In the last 20 or 30 years, we've been very carefully managing that dynamic and have been pretty successful in minimizing flooding downtown. But for many people who grew up here and lived through that time period 50 years ago, it was a key trait of downtown was flooding. Maybe it's that closeness to the water, that dynamic that prompted us 20 some years ago to start thinking about climate change and sea rise. But once again, it was just a few years ago when we really started engaging our community, I guess ourselves as managers, and our community and our elected officials in this issue. We've also, I think, well, for a long time, we've been involved in reducing greenhouse gas emissions, but we've really started recognizing the importance to step that up a bit and get the city more engaged, the community more engaged in emissions. And that's just been over the course of the last year or so. Our high tides are crazy high. I mean, I drive through downtown and I'm almost complacent, almost accepting and accustomed to how high our tides get. This is not atypical to see this high of a tide in downtown at Percival Landing by the Oyster House. So the problem is there now. The risk of flooding is there now. It won't take much to exacerbate that risk, to potentially push us over the edge. If we're projecting 8 inches or 10 inches or 15 inches, however many inches of sea rise in the next 10 or 15 years, that's pretty quick and that's very appreciable given the current dynamic of downtown and its waterfront. We had a great chance to look at this in December, I think it was December 17th, a year and a half ago, when it was a normal high tide, but we had regionally a very low pressure system off the coast. Atmospheric pressures were low. It let a lot of water into Puget Sound, and it really created a tide that was much higher than predicted or anticipated. We did have flooding downtown, water overtopped the shoreline. It was a great chance for us to test our theories, to test our models and our simulations, and see if we really did understand what could happen in the future. It did respond as we predicted, but we will see more and more of this type of flooding in the future. Dr. Feely, as a scientist, studies the how much and how soon. We really don't. We understand that the trend of sea rise is escalating, and given our vulnerability downtown, we have to respond. And our work towards responding is really, as I said as an introduction, is to keep this issue alive in our community, to keep it real. In order to do that, we are incorporating it into our city government. There's a number of key tools we use. One is an annual work plan. And it seems like common sense, you know, it seems almost commonplace that if you want to get something done, you need a plan and you put it in place. But for this issue, it's so huge, it's so monumental, it's so potentially overwhelming that it's challenging to do that. It's especially challenging for local government to do that. So we've gone through a very deliberate process of each year creating a tangible, manageable work plan that we as city staff can implement and increase our knowledge of sea level rise and its implication to Olympia, and then share that annually with our city council, our elected officials, and share that with our community. And through that process, we can just build the knowledge, we can build our ability to adapt, to be resilient, to put things in place. Some examples of work planning, we started off with some really simple questions like, can we get very accurate elevations of the land downtown? We didn't have that. In years past, it's been plus or minus a foot. Now with telemetry and satellite, we can get down to an inch or so. So we've spent a year and a half just building that baseline knowledge of what are the elevations of downtown so we can compare that to potential water elevations. We've looked at engineering studies, and they're pretty academic, they're conceptual. We don't know necessarily much about coastal engineering. We're not from New Orleans and Venice and so forth, but we needed to start building within our community that basic traditional information on how do you build barriers against the sea. So City Council asked us to investigate that, bring them information back on how we would protect Olympia from 50 inches of sea rise. Once again, just a conceptual academic exercise. Hopefully at some point in the future there's a better technology, there's an environmentally better solution, but it's a baseline of knowledge. The more we study it, this issue, the more we realize in a very quantified level how vulnerable we are. And with that, we've pushed in the last couple of years to build our emergency response capability. If we get a projection that 3 days from now we're going to have a massive tide, what resources will we need? What people will we need? Where do they go? What do they do? That's something until recently we've been pretty unprepared for. The annual plan in 2011 was great. We hired a team of oceanographers and coastal engineers to do a very comprehensive study of Bud Inlet as well as downtown in our built environment and build the scenarios, build the simulations that could help us understand the different dynamics of downtown flooding. It's on the webpage. It's a good read on storm surge and flood evaluation. It's a great study on Bud Inlet too. It's on the city's webpage if you're interested. From that came a ton of information. Some of the more straightforward information was just a series of depictions like this, showing Bud Inlet and downtown. The blue over downtown, of course, suggests water inundation. This slide is just an existing condition. This level of flooding could happen tomorrow downtown with a 100-year storm event. Granted, it's very shallow water. It may stay in the streets, but it's very widespread water. And then just another simple slide showing 1/2 foot of sea level rise on that. Of course, the extent of the floodwaters increases, as does its depth. One year, I think 2012, we spent time looking at downtown and trying to quantify or segregate downtown into areas of value that we would potentially seek to protect with sea level rise, and areas that we could potentially sacrifice. Once again, a rather academic exercise, but something we needed to do. We needed to identify the high value areas of downtown, both from an infrastructure perspective, a transportation, emergency response, but also cultural, our historic buildings, and so on and so forth. The end result is that we kind of gave up. We concluded that really you either protect downtown from sea rise or you don't. It's so flat, it's a small geographic area. I think as a community, we're left with either we choose to protect downtown or we don't. And at some point, maybe we can't. But for the near term, that's probably the decision that we'll end up making. We looked at seawalls. Granted, that's not what we're proposing to pursue. And once again, I hope there's a better alternative. But we looked at where would you put seawalls, how would you build them, could you integrate them into the landscape so there's an environmental and an aesthetic amenity to them. It's challenging, of course, in a downtown setting. We've looked at temporary barriers and floodgates and a whole gamut of different things. Ultimately, the price tag is pretty outrageous. It's over $100 million to even initiate this work. But given the scale of the work and the time frame that it would take to pursue this or some alternative like this, we need to be thinking about it now. And this is the type of work that takes a decade or more to put in place. So just from a technical perspective, where we're left after 6 or 7 years of these annual plans and this incremental increase in our knowledge, our understanding is that the risks right now are much higher than we anticipated. It's one thing to drive by Percival Landing at a high tide and marvel at the tide. It's another to start quantifying it and really understanding how high the risk is in downtown Olympia. Flooding is today, let alone in the future. With that in mind, we've done quite a bit of work on emergency response as a first step in preparing for sea rise. We're taking the steps to consider construction in a fairly soon time span, 10, 15 years or so. And we need to continue each year to continue to look at options that we could be pursuing. 2 minutes is fine, I'm almost done. One more slide. City Council has been engaged in the issue. I think we're in our about 4th iteration of city policies regarding climate change and sea rise. These are just some addressing sea rise. They start to suggest the city's acceptance of a responsibility to implement a program. In other words, that's been our goal, sustaining this effort year after year indefinitely. And you're starting to see in draft and new city policies that commitment that over time we will be engaged in this dynamic. So our learning curve, our suggestions is that we've strived to take this overwhelming global issue, personally and I think professionally for a water manager, an overwhelming issue, and bring it back down to our community and tackle it in manageable small steps that we can produce an incremental, tangible outcome that we can then share back with decision makers in our community and then the community at large, like you folks. We've been willing to take those small steps because they've been productive. And we've been willing to accept the uncertainty of climate change and sea rise, and I think intentionally not get lost in that, but rather focus on gradual learning and gradual development of that governmental responsibility to tackle this issue. And with that, the clicky, feel free to contact me. There's also information on the city webpage on our annual plans, our annual presentations to the community and city council. There's quite a bit of information there if you're interested, or get a hold of me. Thank you.
Well, it's going to be interesting to walk around downtown Olympia with Andy's eyes when we go over the coming days and start to look at what our downtown could look like under a sea level rise scenario. Next up is Thera Black, and Thera is a graduate of the prestigious Evergreen State College. She serves now as the senior planner at Thurston Regional Planning Council, TRPC. TRPC, since the 1970s, has been a leader in regional planning. Not really I guess it's a quasi-governmental agency. It brings together local governments and is very, very forward-looking and really tries to get our collective arms around what the future is bringing and how can we be intentional about planning for that future in a way that we preserve our high quality of life and we get outcomes that we want. The TRPC recently has landed 2 major federal grants, Sustainable Communities grants, brought in over $2 million from these grants to the community. Sustainable Communities grants, I'm sure you might touch on that briefly. Thera's specialty is really around integrating transportation and land use decision-making processes, and she's going to explain why these two go together, transportation and land use, in such an integral way, and why it's so important to interdisciplinarily bring those two realms together. I can also testify that Thera is the best neighbor you could possibly hope for. We're ex-neighbors, and she is out there, pretty much every day after working a really hard day, beautifying her little section of the neighborhood. It's really quite remarkable. I don't know where she gets her energy, but she'll share some of that with you now. Thera.
Yeah, actually, Reese is a great neighbor, and he's a great landlord too. He's got a great tenants in there now, and so we work on keeping our pollinators happy in our neighborhood. So I'm going to talk with you tonight about transportation, land use, and climate change. And I'm probably going to challenge some of your thinking here. I hope I am, anyhow. You're going to probably expect me to stand up here and say one thing, and I'm hoping that I'm going to say things a bit differently than what you're thinking. But before I get started, I do want to say that TRPC, Thurston Regional Planning Council, is your council of governments. It's made up of elected representatives from all across the region. I'm staff to TRPC. I've been there since 1992. And so it's really worth finding out what TRPC is all about, and I'm happy to answer any questions about that later, or follow up with me afterwards. But actually, I'm going to click back just a little bit here. We're going to talk about one of the projects a little bit that came out of that grant that Reese was talking about. Sustainable Thurston was adopted by TRPC back in December. And Sustainable Thurston, let's see, where am I pointing at here? Here we go, yes. So it did result in a plan, regional plan for sustainable development. This is a really comprehensive plan. We had input from people who never have been involved in local government before, getting involved, caring about what their community is going to look like in the future. And so it was a really exciting process in that regard. I will say that I'm going to touch on just a very tiny part of that plan tonight. You're going to hear me talk about the environmental aspect, but this plan, like all good sustainability plans, is about much more than the environment, and I hope that in your coursework you're thinking about the environment, not just the natural environment, but the human, the social environment, and the economy that sustains us all too, because without a strong economy and without that good societal network, environmentalism is sort of a luxury for rich people to talk about, and we miss a lot of importance here. So what came out of the Sustainable Thurston process is that there's a sense that the course that we're on, despite our best efforts over the last 20 years or so to manage growth in a responsible way, that was not taking us on a sustainable path, that we were going to incur too many costs and too many impacts that were not acceptable for this community. And we were pushed hard by the community to think bigger and broader and more progressively than, let's say, government typically does. And so, so it was a real interesting process. It was very rewarding, very exciting to get to be a planner working on that. The preferred alternative, when everything was said and done, the preferred alternative said that basically as much as we have tried to curb our rural growth, we're going to do even more. And that over the next 20, 25, 30 years, no more than 5% of our future growth is going to locate outside of our urban areas and into those rural areas. That is necessary so that we can meet other objectives like no net loss of farmland, minimal impacts on our forest lands, minimal encroachment of impervious surface on high quality watersheds. Andy's focused on downtown Olympia. We're looking at TRPC at the whole region. And we already have a lot of degraded watersheds, and perhaps those are better places for us to be growing in the future than into more of our pristine watersheds. So, but to do that, and to have in the future 72% of the people who live in the region being close enough to basic urban goods and services to walk to them, to be able to do that is going to take a lot of change. It's going to be hard, and a lot of it gets down to transportation and land use. And so I like to say everything gets back to transportation, and I'm going to see if I can make some of that case for you here tonight. So transportation, this region has had a very progressive attitude about transportation for a very long time. And for anybody who doubts this, go to many other parts of the country and see how many sidewalks that you find, bike lanes that you find, Class 1 trails that you find. This region has been investing in its transportation infrastructure with this notion of multimodalism, travel for all people, regardless of mode of travel. We've been making these investments for well over 20 years. But hand in hand with that is the land use to generate the bike and walk and transit trips that we've been investing in. So we have invested tens of millions of dollars in sidewalks and bike lanes. And I know that these are fighting words in some circles, but I'll say that a sidewalk by itself does not make a neighborhood walkable. You need two destinations that are close enough to walk to if you're going to realistically be able to give up your car and walk to somewhere instead of driving. So transportation and land use in this region are inextricably linked. And as a transportation planner, frankly, I spend more time talking about land use these days than transportation. That's my reality. So the part that I think is going to challenge some of your thinking is that the work that we've been doing over the last 20 years is actually exactly what we need to be working on for climate change. We are not proposing a lot of radically new ideas or measures to address climate change, because really, if we get our transportation and land use right, if we do it the way we need to do it for all these other community objectives, livability and lowering the cost of travel for households, and being able to, like I said, generate bike and walk and transit trips, and all of these, access to goods and services, and people who are of mixed incomes to be able to get to medical and shopping and all of that conveniently and safely. If we build our communities for that, That is the best thing that we could be doing in this region for climate change. Now, what I have up here in the way of these graphs are data from the Thurston Climate Action Team. We worked with them on Sustainable Thurston, and they're now off and running and doing their thing. And they did a baseline inventory of greenhouse gas emissions in 2010 for the region. And what we have up here in the pie chart, basically the blue is the greenhouse gas emissions generated by our built environment. And the huge apricot-colored wedge is greenhouse gas emissions generated by vehicles. When we break that down even further, and we've got the built environment over here on the far side, the apricot on top of the blue, built environment residential activity, the biggest generator of greenhouse gas emissions in the built environment. And in transportation, that great big maize sort of colored thing are passenger vehicles. So we can talk about ships coming in and we can talk about trucks, but it's our passenger vehicles that are really the problem. Now I really like this. This is some work that was generated by EPA and others. And what this looks at is this relationship of how we build our community and its impacts on the environment. And so a couple of terms, conventional suburban development, that's what basically most of Thurston County is. The vast majority of Thurston County is this. Single family residential that's surrounded by more single family residential, that is conventional suburban development. And then another concept is transit-oriented development, more mixed use, higher density, closer destinations or closer to each other. And so we're going to compare and contrast these, and we're also going to compare and contrast between the gray bars, and that's not energy efficient, not green dwellings, and the green, which are green dwellings, green transport buses, Priuses, these are passenger vehicles. And so when we look at single family detached, most of what our housing is here in the Thurston region, what we see, these are the energy costs associated with the residential units. About the same, doesn't matter whether you're living in conventional suburban development or transit-oriented development, your energy housing costs are the same. And it's likewise, if it's a greenhouse out in Capitol Forest has the same energy consumption as a greenhouse close in on a transit corridor. The big difference here, though, is in your transportation impacts on CO2 emissions and energy consumption. Obviously, the further out you drive, the more spread out we are, the more of a impact that you have. So when we move ahead and we look at attached housing, this would be townhomes, duplexes, triplexes. Again, we've got better energy efficiency than we had in our single-family detached. Same thing with the green, and we see our transportation impacts the same. And then my favorite one, though, is the multifamily. And so multifamily is the single most energy efficient housing that's out there. And even if you don't have an energy, don't have a green home, your energy impacts are half of what they are in a traditional single-family detached dwelling. My favorite part, though, is that if you live in just a plain old multifamily house, an old one, you haven't had the energy upgrades, energy efficiency upgrades, and you drive a Volkswagen bus, you have a smaller energy impact than even the green development further out there. So as a planner, I'm a little disturbed at how many people get excited about living way out in the country and they've got their green home, and it's like, yeah, knock yourself out there. That's really doing a lot for our environment. So this is a really interesting little time series. I'm going to click through it fast here, but what you're going to see is the growth in Thurston County since 1910. We have building permits all the way back there. The blue is residential development, the orange is commercial development, and transportation and land use have a synergistic relationship. We grow up around our transportation infrastructure. And what you'll see is from 1960 on, boy, we sure did start to spread out a whole lot. And so that's really the crux of our problem, is we're not starting from scratch. In 1990, the Growth Management Act was passed, and we implemented urban growth boundaries that said this is where growth is going to go in the future. People would say, maybe the horse is already out of the barn on this. But we've really been working to try to keep that the growth concentrated in our urban areas. And this is actually our development pattern today. And as you can imagine, not very many of those people out there are going to be able to bike or walk instead of drive. Now, again, some people say, this really didn't do any good. Look at how much growth is out there. But we actually went back and looked at the building trends and the amount of vacant developable land that's out there. And if we had not implemented the Growth Management Act and implemented the growth boundaries, that is probably pretty close to what our land would look like today. Instead, it's this. So it really, where you live makes a huge difference. It makes a huge difference in a number of places, in a number of ways. So how much driving you have to do. You may be car dependent, but you don't have to drive as far if you live in a close-in area as when you live outside, whether it's going to work or going to shop. The average household in Thurston County drives 22,300 miles a year. But that varies wildly. If you live in the city center or along the corridors, whether you're driving or walking or biking, you have a lot of choices, and you're driving about 60 to 70% of what the average household is. Compared to that, maybe that really green home out in the rural areas, you're driving about 130% of the average. This just shows the darker the blue, the lower the vehicle miles of travel. And we know in our planning circles, vehicle miles of travel is a surrogate for greenhouse gas emissions. A concept that's out there that was integral to Sustainable Thurston is quite controversial in some circles, is this notion of walkable mixed-use districts on our urban corridors. That these are to try to create something that does not yet exist in Thurston County, which are truly walkable urban places where you don't actually have to have a car to be able to get around. And so we talk about corridors in this notion, this idea of quarter mile either side of a corridor. And people say, well, where'd that quarter mile come from? That's going to impact my neighborhood. But in the real world, empirical evidence shows that a quarter mile is about as far as most people are willing to walk for a utility trip. I'm not talking for exercise, I'm not talking walking the dog, but I'm talking like I'm going to leave the car at home and I'm going to walk to the grocery store and buy groceries and carry those groceries back home. A quarter mile is about that distance, and so that's why we pay attention to this notion of corridors and what's going on either side of the corridor. Are we building communities that can create those bike and walk trips? These are, these green bars represent from 1991 onwards where growth has occurred in our region, and very, very little of it is going into those places where transit, biking, and walking makes sense. We got down, in the early 2000s, only 4% of our residential growth was going onto those corridors. We're hoping that maybe if we're smarter about market forces, we can keep bending this trend. It's starting to go up, and people like me are working on this. But we'll see where it goes. There's a lot of opposition to the type of development that is actually needed to generate these trips. We hear from the public over and over that they want to have transit access. And if that's the case, people need to live where transit is. Transit is not efficient motoring all around the community to pick people up. So the closer you are into city centers and corridors, the more transit opportunities you have. People say they want a walkable community. They don't want to have to drive everywhere. Again, where you live is going to influence those choices, and you're going to have more of those opportunities in the close-in urban areas than you are further out. I will say, though, that we do have some opportunities, even if you live out in the rural areas. You certainly can do things like telework and flex schedule. Working from home 1 day a week reduces your single occupancy trip to work by 20%. If you can work a compressed work week, I keep mine at 60% just by teleworking and flex schedules. I don't want to minimize it. We have huge challenges. We're a car culture. We have grown up around cars. We have to do a lot of retrofitting to address these old issues. We have a lot of stormwater impacts, not just downtown, but other places. We are a car culture. But I would say that if we are growing more efficiently, addressing some of these threats is more efficient for government, and we can all be doing our part a little bit more to minimize it. This is a region that values active transportation. We invest heavily in our non-motorized infrastructure. This is a region that goes back and retrofits. All new development that's come along since about 1995 brings with it its own sidewalks and bike lanes, but we didn't used to always place a value on that. And so actually some of the growth that's coming here today is helping to pay to retrofit infrastructure and add these facilities where they don't exist. We're making new connections all the time, whether it's new street connections, trail connections, pedestrian pathways to transit. New connections are really an important part of our strategy. So is infill and redevelopment. And this is probably the #1 transportation issue that we have to figure out if we're going to be successful in mitigating some of our impacts for climate change. We also, engaging the community, coming out to meetings like this tonight, and working with our stakeholders in the community is an important part, and planning for the next generation. Frankly, in 40 years, I'm probably not going to be here. You guys are, your kids will be here. They're the ones that we need to be planning for. And that creates a real tension because the people who are participating today are not these guys. They're their parents or their grandparents. And so how do we make sure that their voices and their concerns are considered as well? So I'll just end on this note. I like to say that, controversially, that growth is a finite resource and we need to use it wisely. Growth can help us unwind out of this auto-dominated environment that we have built over the last 100 years. And so how we grow is perhaps more important than how much we grow. And so I think with that, I'll leave it. I hope that sort of gets some of you scratching your heads, and I look forward to some interesting discussions and challenging questions in the second half. Thanks.
We're ready. Thank you for promptly gathering yourselves. We're going to get going here. And Bethany, Kelly, and Lauren, the women leaders of Mesa, are going to come up. Yeah, now's your chance to thank them. They're going to be the question askers, right? Okay.
Thanks. So this one is for everybody. We'll start off with a group question. So as leaders with extensive knowledge surrounding the impact of climate change, how do you stay resilient in the face of what feels like tremendous existential crisis for life on Earth? Take it away.
We've started that in.
Oh, really? Can't we get on to more profound questions and skip the trivialities here? Geez. Well, I guess just from the emotional standpoint, I reside for the most part in the realm of just how exciting it is to be working with people who are really working on transformation and feeding off their energy and their passion for positive social change. It feeds my soul, and every once in a while I need to get out in nature and revel in the magnificence of our planet, and so I try to make sure that there's lots of breaks built into work life. And for the most part, other than that, I'm in denial, and I try not to think about it too much.
Yeah. I think that's one of the joys of working with young people. Because young people see what the future can be. And when you can see what the future should be and can be, you're willing to say, let's go for it. So for me, it's doing things like I just did tonight, is getting that dialogue with people who have the right vision.
I enjoy science. I have a science background, natural science background, and then became an engineer because I felt that was a means to implement science, natural science. And I've always been intrigued with water, just wholeheartedly intrigued. For me, working with science in a city and trying to correlate the dynamics between the natural world and the built environment and the people who live in that environment is fascinating. I can't think of anything more interesting to do as a scientist than to work in that dynamic. So it's fascinating. More pragmatically, I'm also an engineering or a environmental manager in an urban area, so I'm used to disappointments and inability to meet environmental goals. So, I mean, we break things down, as I suggested during the presentation, into manageable pieces, and we make them interesting, and we learn from them, and we try to be creative and innovative. We like to communicate. So with respect to climate change, we're always breaking things down into smaller pieces that we can find knowledge from and find interesting dynamics and then share them with people. So.
Wow, it's a great question, and I think I subscribe a little bit to what all three of them said. I do think that it's in my area, as you picked up tonight, this notion of transportation and land use, I actually do see progress that we're making. And maybe I just put some of the blinders on for some of the other stuff. It's too much. I can't take it all in. I can't, whether it's climate, whether it's social issues, homeless issues. I mean, there's so many issues out there. And so I think perhaps I'm guilty of being a little bit desensitized to it. But in some regards, just head down, doing my part, believing that it's making a difference. But I think also when it does get to be really overwhelming, I feel like there's a real important role for bearing witness. And so I think that sometimes we're seeing things and witnessing things that future generations won't ever see or witness. And so it's incumbent upon us. It's the privilege of witnessing some of this. And so I just try not to dwell on the sadness of it and instead the beauty of it.
All right, this next question is for Andy. We had a couple similar questions. So if Capitol Lake were drained and restored to an estuary, wouldn't it be more resilient? How would this transformation affect Olympia's sea level rise projections?
Capitol Lake has been studied for a long time by the state, and I wish we could just take the dam out and be done with it and proceed. It's from I guess my perspective, it's silly to have a dam there. We could manage sea level rise quite adequately with the dam out. It would create a new challenge, but it's not insurmountable by any means. So take the dam out.
Okay, this question's for Dr. Feely. This says, you talk about CO2 greatly affecting ocean acidification. What about other playing factors that change ocean chemistry, like pollution, Fukushima radiation, the BP oil spill, etc.? Do these compound the changes being seen, and do your findings take these factors into the equation?
I've never been asked that question before. Actually, many of the other concerns that we have that are related to climate change, such as increasing temperature and decreasing oxygen, are related to acidification, and our models do take that into account. Other areas of pollution, for the most part, are localized and they're not global, so we have not taken into account in our models things like, for example, oil spills and their impacts on acidification. I haven't seen any kind of analysis like that. It's a pretty good example. Fukushima is an example of a radiation source, and that radiation source is extremely measurable, but for the most part, except for the local impacts, it's not toxic. So again, it would not be a global issue compared to acidification. So you have to take each kind of pollution impact and decide
whether it be a local effect or a global effect, and how the interactions of those pollution events with other types of environmental concerns. And as we as scientists do that all the time. But you know, this is still a very early stage. Ocean acidification really has been on the radar since 1998, and so we're still learning how those interactive effects work. And my expectation is that we will see interactive effects only with climate-related processes for the most part.
This question is for Ms. Black. Are we planning a more wide-scale mode of transportation for commuting across the Puget Sound area, such as the BART train in San Fran or the subway in New York?
Oh, boy. We, baby steps. We're working right now to get an HOV lane on I-5, and congestion pricing, which is sort of a geeky concept, but it would basically say it sort of treats I-5 like a utility and says if you're going to travel in the peak period, you're going to pay for it, and if you, if you can shift your time. But getting HOV on I-5 would be phenomenal. Right now, a study that I'm working on I-5 up at JBLM, the analysis shows that transit today, transit and van pools and carpools are taking enough traffic that would fill up about 80% of a travel lane if everybody got back into their cars. So it's a hugely valuable mode of transport. And I'm not at all dismissing the notion of light rail or commuter rail, but pragmatically, we are a very small region, and we're very suburban in our land use patterns, and we are very we have very small economic clout, and so it's not a practical opportunity for us. We are working closely with Sound Transit. Sound Transit is down to Lakewood today, and we have talked with them. Just for point of reference, it would cost just to get the rights to run the Sound Transit commuter trains on the Burlington Northern Santa Fe tracks, that's how commuter rail runs, would cost us $185 million just for the right to run the train on the tracks. So, and to join Sound Transit, each household would pay about $100 a year in taxes, and they say we probably would not even get that service until after 2030. So when I say, so I'm not being, if we were in a different part of the country, I'd have a very different spiel for you, but do not overlook the value of just improving the way the infrastructure that's out there today, how it functions, and let's give a time advantage to transit and van pools and carpools, and let's start charging people, especially people who are driving by themselves in their cars during peak period, and I think that would make a remarkable difference in I-5 mobility.
Just a little bit of a follow-up. I've been talking to a lot of thought leaders and experts in sustainable infrastructure in Oregon and Washington over the last 2 months, and I'm not finding that many talking about the potential to use the I-5 right-of-way that we have, in particular the median between the lanes, potentially as a high-speed rail corridor. And I think and I'm asking, well, why hasn't there been a serious analysis of that done? And it's sort of like it doesn't fall in anybody's job description. It's sort of outside of any agency's mandate to really lead that and conduct that. And
Dixie Lee Ray. Dixie Lee Ray, Dixie Lee Ray's objective was to get, was to claim some of that right of way. And the challenge for us today is, especially as you look further north, from edge of right-of-way to edge of right-of-way, it's dedicated to cars. And so I think it could be, me personally, I look at it, I think you could also combine it with utility transport, power, utility. There are some really cool, if you're into looking a little bit on the seemingly science fiction-y side of things, there's some really neat analyses that are being done, but not by us and not by, the Puget Sound Regional Council or the DOT. There's nobody here from DOT, I hope. Well, if there even, the DOT, is going through a transformation, and the DOT has been the highway department for decades. And so to get the DOT now at the table talking about just even getting, HOV down to Thurston County is a big deal. They are not, they would be the likely leader of a discussion about using the I-5 right-of-way, but that's not. And the other thing I'll just throw out really quickly on this is think about all the overpasses on I-5. You'd either have to have the rail above it or below it. And again, it's not to say that it can't be done. We can engineer anything, but the cost for it, the cost per trip served is tough. It's a tough case to make.
All right, this next question is for Mr. Roth. Given the rise in energy demands with solar and wind having efficiency caps, are limitless clean technologies like fusion energy being pursued and promoted in the public eye?
I'm not used to being called Mr. Roth, but that was...
That's you, sir.
I don't see, I don't hear a lot of conversation about fusion being promoted in the public eye, or nuclear power perhaps more so as a potentially carbon-free energy source that would be baseload power and has certain advantages. Although purely on an economic standpoint, it's doesn't seem to be nearly as effective as other resources. For example, now we are enjoying the equivalent of 2 Grand Coulee dams worth of energy in the form of the efficiency and conservation resource that we have invested in over the last 20 or 30 years. An enormous resource that comes in at about 2 cents a kilowatt hour. That by far the cheapest resource that's out there is this conservation and efficiency resource that we've tapped, and there's still tremendous potential for that clean resource to be developed. But I'm not a super expert at all on nuclear fusion, so I don't really know the status of the technology or its potential commercialization. I don't know if anybody else is on top of that, but I have not heard much conversation about it.
This question's for Mr. Hobb. Can you speak to the type of stormwater infrastructure needed in cities like Olympia to withstand flooding?
Well, Olympia has about 185 miles of stormwater pipe and about 1,200 stormwater ponds and different type of facilities to store and treat stormwater. It's a huge investment, and it's not enough. But it's not necessarily, the limitation is not necessarily flooding. We can manage flooding now. That's just an engineering feat. It's just a physical dynamic. The real question with stormwater is water quality and habitat protection and groundwater infiltration and so on and so forth. The questions around stormwater these days are environmental, in my mind, rather than flooding. Olympia used to flood terribly. In 1990, the city really bumped up that effort to control that, and we have. So it's entirely feasible to do through traditional engineering and spending money. It's the environmental implications that are challenging.
Dr. Feely, are pH changes in Puget Sound more severe or less severe than on the outer coast exposed directly to upwelling?
That's a great question. We did a number of studies with the University of Washington PRISM program to study the impact of acidification in our region here in Puget Sound. We studied most Main Basin of Puget Sound as well as Hood Canal. And what we found is that same upwelling process that we saw along the coast actually gets in through the Strait of Juan de Fuca and then permeates down into the Main Basin and Hood Canal. So you get that acidified waters going along the bottom. But in our local regions, we also have the added exacerbation of local sources of acidification that add to it. This is caused by additions of nutrients that produce phytoplankton, and when that phytoplankton sinks to the bottom of Puget Sound, then it remineralizes back to CO2, and so those bottom waters are actually enriched in CO2, and so that's another source of acidification. The State Department of Ecology has been working on this to identify regions that where these local impacts are quite important. So what we saw in our studies for 2008 and 2009 and 2010 was that in Hood Canal we actually see pHs as low as 7.4 or 7.3, lower than anything we see on along our coast in any region we've studied thus far. In the southern part of Puget Sound, and they're about 7.4 or 7.5, again lower than what we've seen on the outer coast. And not only do we have the nutrient sources that contribute to the acidification process, but our local source of CO2 from transportation also adds to the burden of CO2. And we've seen this on our moorings that the University of Washington puts out. So we can see that. So an interesting question will be in the future is if we change our transportation practices, will it have an impact on the local acidification of Puget Sound? We don't know the answer to that yet.
Ms. Black, what plans are there for low-income or suburban families or geographically dispersed families access to transportation in Thurston County? For example, what, if any, ways are you strengthening social networks to support access to transport? People that, can't necessarily telecommute.
And that's a great question, in part because up until recently, we always thought about housing affordability as just the cost to put a roof over your head. So if you were spending more than 30% of your income on housing, that was considered to be unaffordable, but if you were spending 30% or less, that was considered to be affordable. We're now, across the country, we're also factoring in transportation costs, because a cheap house that's way out in the boonies and you've got to drive everywhere that you go is not a cheap house. And you're making choices about, are you going to put food on the table or are you going to put gas in your car? There's a lot of tension here between what is government's role and what is individual responsibility. So I'm going to speak on the government side of things and maybe talk afterwards about the personal responsibility. But this is the real important thing about trying to get more mixed income housing along our transit corridors, and where people can actually walk to stores or to medical services or to schools. There's a huge social contract, I think, behind a lot of our work on urban corridors, because if we don't provide more housing opportunities there, it's not all of our boats are going to float on the floods that Andy's trying to keep from happening. We do not want to displace people. We're working real closely with the Housing Authority of Thurston County at the beginning of our Sustainable Thurston process. As we were sitting down working with them, they hadn't really put this connection together between transportation and land use. So now they're approaching this differently when they issue Section 8 vouchers, or when they're working with developers to locate new subsidized housing, that is actually close to a transit corridor and not on the outskirts. The challenge, though, is that the land is usually more expensive closer in. So government provides multifamily tax incentives and other methods of trying to lower the cost of providing the affordable housing choices close in. So there are a whole lot of different things going, but this really gets back to this notion of building transportation efficient communities, and it really affects housing affordability. If people have to have 2 cars to support their family, that's a huge household budget burden, and that's money that's not available for medical or going to college or doing fun things with your family, and it's a real social issue for us.
Okay, for Mr. Hobb, how does planning for sea level rise fit with new buildings like the Children's Museum or City Hall? What is the expected lifespan of these buildings and other newer developments?
That's a good question. We were criticized heavily. Actually, it was embarrassing. We were caught off guard when the new City Hall was proposed for downtown on 4th Avenue. It was built, 4 years ago, 3 years ago, somewhere in there. Ultimately, we ended up raising the elevation of the first floor on that building considerably. And who knows what the right amount is. It's probably not enough, but it's the right approach is to start raising the elevation of the first floors downtown. We do that with all new buildings downtown. It's probably not noticeable. We don't raise them so high that they create an architectural burden or a financial burden, on the building, but it is there. That's a city policy now. So hopefully over time, there will be a more consistent finished floor, first floor, finished floor elevation in the buildings downtown. 20 years from now, there will be more consistency, and then we can start managing to that elevation in our flood response efforts. Right now, it's just a mixed match of high and low buildings, so we always have to manage to the lowest elevation. So it's intentful. And who knows, as I say, who knows what the right elevation is. At this point, it's just an intent and an acceptable response.
So we're coming to the end of the program. I have a special question I'd like to throw out there, and then maybe we could do one more final question, or you got two really good ones? All right, we'll squeeze those in, okay? All right, my special question is for Thera, and you guys, if you have a vignette too that you want to share, that would be great. But I would like you, if you're willing, to tell the story of how you got your job at counseling students who may be looking for jobs that are fulfilling and meaningful in the near future.
Yeah, sure. When I was at Evergreen in 1989, Kendall Bear was my faculty, and we had done some group work, and then we were going off doing our independent contracts. And just based on the group work that we had done, he sort of pointed me towards somebody named Kathy McCormick, who worked for some agency called Thurston Regional Planning Council. And funny part of the story, I'll make it really short because I know we're paying attention to the time here. Things have really changed at Evergreen since I was here. Let me tell you, we're paying attention to the time. But when I called Kathy, introduced myself, and said I'd like to know if I could get an internship with her, she was like, oh, honey, I'd love to, but we don't have any money to hire you. And I'm going like, hire me? Like, are you kidding? Like, oh my goodness. Like, no, I'm paying college tuition. So anyhow, so that got me in, and that's how I got introduced to TRPC, and I was working on a regional transportation plan that I had no idea I'd ever become a transportation planner. And then when I graduated from college, I got a paid internship at TRPC. I got a 6-week position, and 22 years later, I'm still there. I did everything I could to make myself indispensable, and there's no grunt work too low for me to do, and and I could do anything. I don't know how to do it, but I'll learn how to do it. And so that's how I got there, and it's exactly where I wanted to be. And it's I always like to say it's like getting paid to go to college. It's fabulous. It's just terrific. Yeah.
Great. Thanks. The last two questions. Great questions from folks.
Really great.
Yeah,
really excellent.
Thank you all. This one is for everybody. And so I guess this will be the last question. Are there efforts in your workplace to increase diversity? And how effective are these? For example, an increase in historically underrepresented communities, people of color, and women at all career levels.
I could be really quick. The Center for Sustainable Infrastructure is brand new, and there's one person that is
employed in it now, so it's aspiring to incorporate diversity as we grow, but at this stage, it's not very diverse.
Well, within the federal government, we have a diversity program that we follow very quickly, and so for all applicants, we have to address the diversity issues right away and make sure that we're completely fair in the selection of candidates, and it's a requirement. We reach out to minorities in particular and try and make sure that they're part of the review process for positions.
Well, also City of Olympia, another government entity, I echo the same comments. However, it is very noticeable, the increase in diversity just in the last 10 or 20 years that I've been there. It's admirable, it's good, and it's noticeable.
And I work for a very small agency, government. Likewise, we have laws we comply with, but most of our diversity tends to come in from students or people from other countries. On the technical side of things, we're not pushing out the folks who can do some of the technical work that we need to have done. And so, I've worked with Native Chinese, Native Indian, and perhaps in the not so distant future, Persian folks who, we just don't see it sounds kind of crazy, but on the technical, when we're looking to fill recruit a modeling position, the diversity is actually not for your, typical, what you'd see up here, Caucasian, college, we're just not. It's a very different world that we live and work in. A quick plug, though, I do a lot of work with the Transportation Research Board. It's just sort of my own personal professional development, and I love talking with the students of color who are coming up through the college programs and talking about how to get into planning. And things like this, coming out here tonight and talking to folks, it's really fun. A lot of people don't even know these fields exist. And so it's one thing to reach out when you're in a recruitment process. It's a whole other thing to go talk to folks who are thinking about career paths and helping them to discover, because government will, we all operate with diversity goals and objectives in mind, but if nobody comes through the door, that doesn't help us. We need more people more people of color, more people of different abilities to be thinking about these careers before we are doing the recruitment, so they'll come walking through the door for us.
Related to that, Dr. Feely, I imagine you're seeing a lot more graduating scientists, PhDs, a lot more women coming through the door applying for these positions, I'm guessing, and I'm wondering whether that's true and whether there are people of color that are going into the sciences.
Well, actually, in oceanography in particular, there are more women getting PhDs in oceanography than men, interestingly enough. And yes, there's programs within the universities that particularly address minorities and to make sure that they get into the graduate school programs. So I think it's been a tremendous change over the last 20 years that I have seen. And even within the federal agencies, if you look at the federal agencies, the increase in number of women taking federal positions has increased dramatically as well.
Well, I think that's a good note to end it on. Could you join me in thanking this distinguished panel? I think you didn't disappoint us. It was a very fascinating discussion. Thank you guys very much.